right, so everybody, welcome to Hi Marcia's master's thesis defense. So Hi Marcia started as a master's research track student in fall 2019, and we have convinced her to continue for her PhD, which we're very happy about. She has collaborated with other students on several projects, and I had forgotten all of these until I started writing them down. She's worked with Kritika Garg on analyzing archived Twitter and revisiting our group's previous work on robots versus humans in web archive access logs. She's worked with PhD alum and now LANL researcher Sean Jones on storytelling tools for web archive collections, and also with Dr. Wu's group on extracting metadata from ETD. So she's done a lot of stuff in addition to her thesis work. And so we're excited to have her present this work today, and we're looking forward to continuing to work with her as she continues in the PhD program.
Okay, good afternoon, everyone. First of all, I would like to welcome you all to my master's thesis defense. I'm Himarsha Jainathi, and I'm a student of the Computer Science Department of ODU, and also I'm a part of the Web Science and Digital Libraries Research Group. So, social media is a popular way in which people interact with one another. Some of the most popular examples of social media being Facebook, Instagram, and Twitter. Now, in this table, we have reported the monthly active users for Facebook, Instagram, and Twitter, as well as the Google Scholar hits, which returns if we just type in the keyword Facebook, Instagram, and Twitter for each platform. And also we have reported the active user to Google Scholar ratio. So as you can see here, Instagram is understudied compared to the other two social media giants. For example, Instagram is 4 times larger than Twitter, but is 11 times less studied compared to the social media popularity and the user base. So this brings us to our research question: how can we facilitate the discovery of all of the users' archived Instagram posts? So in this research, we are trying to find out to allow easy discovery of Instagram posts in web archives. To illustrate the difficulties one would face while trying to find these Instagram posts, we have, I'm introducing a character called Maya, who is a researcher studying conspiracy theories and conspiracy theorists on by studying social media accounts. So this is the Naomi Wolf is a well-known conspiracy theorist. So Maya decided that she can study the social media accounts, specifically Twitter and Instagram accounts of Naomi Wolf. And this screenshot shows how her account on Twitter is suspended as of October 25th, 2021. So that's her account got suspended after tweeting anti-vaccine misinformation. So this is a common scenario where social media platforms often suspend accounts based on various reasons. To give a couple of more examples, Kanye West's Instagram account got suspended and reinstated a couple of times within the same month for posting anti-Semitic comments. And also, recent acquisition of Twitter by Elon Musk shows how even though an account is suspended, it may be reinstated after a while. So one such example is Donald Trump's Twitter account. So yeah, accounts can get suspended, but posts also can get taken down by platforms or even deleted by the user. Similarly, not just the accounts or the posts, even the platform itself can go away. Now, luckily, we have web archives, like the Internet Archive, that preserve the web content, including social media accounts. So, as you recall, Maya was having trouble accessing Naomi Wolf's Twitter account because it's no longer available on the live web. So she could use Internet Archive's Wayback Machine to go and access mementos, which are also the archived copies of her account on Internet Archive, also referred to as URIM. And as you can see on the screen, this is a memento of her Twitter account, and it's captured, or like it's archived on February 13, 2015, which is also known as the memento date time. Now, Maya used the Wayback Machine's user interface to look for all the mementos that are available for this particular account. So this interface is also known as the time map, which is also known as URIT, which is a list of mementos that belong to a particular URL. So for twitter.com/Naomi R. Wolf, the account page is saved 490 times. But if you look at the individual tweets of Naomi Wolf, for example, if you use twitter.com/Naomi R. Wolf, which is the username of her account, /status, which will lead to the individual tweets of her account, with a star at the end on the URL lookup, which is also the star is indicating to match everything that begins with this URL prefix. So you can see there's more than 100,000 URLs, which means even more mementos, more captures. So the account page, which people know how to find, is only archived. It was only archived 490 times, but these individual tweets, they are archived a lot more times. And Maya thinks, okay, this is a good way for her to find out all of these individual tweet IDs that are hard to find otherwise. So as a next step, she started looking at the Instagram account of Naomi Wolf, which is which looks like this, and the URL is instagram.com/Naomi R. Wolf, which is the username of her account. So if we look at the number of mementos available for her account page, Instagram account page on Wayback Machine, you can see it's only archived 6 times. Now, she thinks she can use the same way that she tried to find the individual tweets of her Twitter account to be used to find out all the individual posts that are posted by her Instagram account. But unfortunately, she is not sure which URL prefix to put in there to get the results. So that's when she noticed that the URL, this is a post in Instagram, and the URL structure is like instagram.com/p/unique ID. And if you see clearly, the username is not included in the URL. So if she tried doing instagram.com/p/star to get all the variations or all the captures from the Wayback Machine interface, and there were 10,000 URLs, but she noticed that these are not just for Naomi Wolf's post, because it doesn't have any username included in the URL. So these are like all the Instagram posts in the Internet Archive. So the takeaway here is that there is no left to right hierarchical construction of URLs in Instagram, similar to how it is as how we can do it in Twitter or Facebook. So if the researchers or any web archive user trying to find these archived Instagram posts, they have to know the exact URL of the Instagram post to look for mementos. So just to revisit the research question, in our work, we try to build different methods to allow discovery of Instagram posts of a specific user's post by different methods in mind, like different approaches in mind. One is to allow such prefix queries that we can do in Facebook and Twitter, and also to allow someone to find all the posts in the post URLs for a particular user. So, for example, there was a report by CCDH, the Center for Countering Digital Hate, who identified 12 prominent figures who are spreading misinformation on social media. They were known as the identified as the disinformation dozen. So a recent study, like followed by that report, a recent study by Bragg et al. Studied archived Instagram account pages of this disinformation dozen, because obviously after this report, most of these accounts are no longer available on the live web. They got suspended because they were identified as prominent accounts that are spreading misinformation. So Bragg et al. Went back and looked in the archive, and they studied the archived accounts. And the main point here is that if it was possible, if there was a way that they can look into like all the post URLs, so they can find all the posts that belong to this account, these 12 accounts, they can easily study those posts as well, not only the account pages. So the rest of the presentation will be organized as below. So I'll discuss about some of the concepts that are needed to understand the rest of the presentation and our approaches, and the implementations, followed by exploratory evaluation. So let's step back and try to understand some of the questions. And the Instagram posts are nothing but HTML pages. So you see here on the screen is a HTML page. You see on the left side of the screen a post on Instagram on the live web, and this is the source code. If you see Weave source, you are able to see that this is the HTML that constructed that page, and we can use browsers to parse that HTML and render the web page. So the one thing to note here is that there is actually additional metadata in this HTML that is not always available on the directly rendered page. So HTTP is a protocol that used to connect web browsers and the servers. So it's like a request response system. And if we make a request for a resource from the server, like the client or the web browser makes a request, and the resource will be returned back to the web browser. And in this case, it is a HTML representation of the account page. Sorry, post page. Now, the kind of resources we are interested in this study are the Instagram accounts and posts. So this shows Instagram, Facebook, and Twitter account pages of Katy Perry and the point to note here is that you can see that they follow similar URL structure: facebook.com/Katy Perry, twitter.com/Katy Perry, and instagram.com/Katy Perry. She uses the same username across all three accounts, and you can see the username in the URL. Now, if we look into the post URL, we have the URL structure: facebook.com/Katy Perry/post and a 17-digit numeric ID. In Twitter, you can see twitter.com/Katy Perry/status/ a 19-digit numeric ID. If you look into Instagram, this is how it looks: instagram.com/p/11-digit ID. And as introduced before, the username is not included in the URL. So if we look at all three of them together, you see how on Facebook and on Twitter, the username is preserved in the post URL, whereas in Instagram, you don't see the username. This is a problem, and we know that the URLs are constructed from left to right, and that's how we can do prefix searches to try to find all the posts belonging to different accounts. But unfortunately, we can't do that for Instagram since the username is not associated. So CDX is a type of index which web archives are using to provide metadata from all the records in an archive. In the screen, I have put a curl command which shows a request to the CDX, which what the Internet Archive use. It's also called as the Wayback Machine CDX Server API, which allows access to the CDX files in recorded in Internet Archive. So if we do a URL search with the URL key facebook.com/katyperry/star, we will get this kind of response. This is just one line of response with a limit 1, and you can see that the URL, the response contains a URL key, which is a much sort-friendly URL of the original URL that's requested, a timestamp, media type, the status code, the file size, and also a digest of the payload. Now, CDX Server API also allows prefix searches. So what we can do is with the URL facebook.com/katyperry/posts, and with a match type set to prefix, we can find the posts that or the URIRs that belong to the Katy Perry's account. So as you can see here, there are 2 different URIRs, 2 different post IDs that are returned. We can do similar queries for Twitter as well. Now, for Instagram, we are unable to do that. That's the whole problem we are discussing. And now let's take a look at our approaches to supporting this type of queries. We are proposing 2 different approaches. First approach is by using or by introducing new WARC revisit records and to update the WARC target URI, which will help us emulate Twitter and Facebook's URL prefix search. So the second approach is by building a separate index itself to create a mapping between the username and the shortcode, and that way we can easily find all the post URLs that are specific for an account. So in this study, we use multiple data sets, and highlighted are the 2 data sets, which is IA logs and IA holdings. IA logs data set is the Instagram access log sample from Internet Archive, and the IA holdings data set is an Instagram URIR sample from Internet Archive holdings itself. And the last 2 data sets are actually created as an output of some of our demonstrations, where we are trying to extract username from live web using Katy Perry's account, which helped us build the Katy Perry live dataset, and the Blake Lively archive is the post extracted from her account page using mementos in her mementos at the Internet Archive. Now, IA logs from the IA logs dataset, this table shows that we have found out the top 20 most requested posts, and also the table shows the account username of these posts. Now we have manually compiled these usernames at this stage. No extraction was done, and from the IA holdings data set, we have 280,000 URIRs, which is like a 0.1% sample of a much larger 285 million URIR sample of like all URLs. And so from this 280,000 URIRs, we filtered 18,000 Instagram service URLs, and then we we filtered 4 Instagram posts, which is following the URL structure /p/, and we were ended up with around 192,000 Instagram post URIRs. Out of this, we obtained a sample and we looked into the unique shortcodes that are available or that were requested by Internet Archive users, where we ended up with 2,427 unique short codes. So let's go into the first approach where we are trying to introduce a new revisit record. So revisit record is a type of a walk record, and the walk records are like a standard file format, which is used to store web archive files or like web crawls. Now, there are different types of walk records, but in our study, we are only interested in the response and the revisit records. So this is an example walk response record to demonstrate how our idea of trying to support prefix searches is going to work. So this is an walk response record for an Instagram post, and interested fields are the walk target URI, which is instagram.com/p/d, which means it's a post with a short code D. And we have the walk date where the record was began to capture. Now, what we are proposing is to, we have the walk response record, that's the typical walk response record of how captures are or how crawls are saved. Now, we are proposing a revisit record, like a whole new revisit record with a walk target URI where instagram.com/kevin/p/d is included, which means that the username is included in our target URI. And this target URI refers to the refers to the URI instagram.com/p/d, the one without the username, and it's set by the field walk refers to target URI and walk refers to target date, which is the original walk date. So what happens here is that if we are trying to create a mapping between these two URIs, the one with the username and the one without the username, and both of these URIs, if requested, would point to the same memento. So this summarizes our implementation. We built a small test archive with by using those top 20 posts in the IA logs data set. So for each of those 20 posts, we built 50. We actually use the CDX API to collect 50 URIMs for each post, which ended up with 1,000 URIMs. So we synthesized these walk records with 1,000 response records and 1,000 revisit records, as explained earlier, with having the username in the walk target URI for the revisit records. So after synthesizing these, we indexed those records and hosted them on Pywayback to replay these mementos and to demonstrate the idea. So to walk you through an example, I'm going to be using this particular account, this particular post that belongs to the account Ichiro Yamaguchi. And if you look into this screenshot, this is how the Pywayback search page looks like. So you enter the URI R, which is instagram.com/p/ the short code. And this, the thing to note here is that it doesn't have the username in it. And when we search, and we will get the 50 captures for that particular post on the Pywayback result page. Now, if we try doing the same search, but with the username included, we are getting those same 50 mementos here. The to actually clarify this better, let's look into a different account. This is the Instagram account of Devin Allen, and in our top 20, there are like 4 different posts that belong to him. So what we are expecting is that if we do a prefix search, we should be able to find out all of these posts that belong to this user account from the Pywayback test archive. So this is how the result looks like. We are using the URL prefix instagram.com/ the username of the account we are interested /p/ star. And by doing that, as you can see, there are 200 results with like multiple posts. And if you look at the summary here, there is 4 different URIRs with 50 URIMs each. This curl request is for the Pi Wayback CDX index, where we use the instagram.com/username with /t with the match type prefix, and then some commands, a Unix command, just to get this summary of how many mementos are there. So as you can see, like the thing to note is that simply by doing this prefix query with the username in there, we only introduced the revisit records to create the mapping, but that would enable us to obtain all the different posts in the archive for this particular user. So moving into the next method, which is here we are trying to take a different approach, and we are suggesting a secondary index that can be used to find the shortcodes that belong to a particular Instagram account. Now, the in the approach one, we use the revisit records. So that means that for that approach to work, we do require the archive to create revisit records for us, and then index them so that can be used to support the prefix search automatically. So what we are trying in this second approach is building our own index separately, external to the archive. So one can first query our index first, and then look for mementos on the Internet Archive. So the proposed index looks like this, and we will have like username, shortcode, pairs, and this would match like if we want to look up, we can look for like, okay, what are the shortcodes that belong to a particular user, and we can obtain it using the index. So when implementing our index, this diagram summarizes the whole idea. So we have the index with the username, shortcode, but how are we going to populate this index? So for that, we are proposing 2 different methods. One is a client-side JavaScript to extract the username from post during the replay itself. And then the other one is by implementing different scraper script to like go through live web and archive web post and account pages to extract the username and fill our index. So also we have developed 3 different API endpoints for this index. One is to write to the index, and then to read from the index. So this add UN index is dedicated to the client-side JavaScript implementation, where it would just listen to receive the username shortcode pairs extracted from there and add to our index. But we do have this get post and get username index, where the get post API endpoint will take a username as the input, and if we request it, it would look up in our index and provide all the shortcodes that belong to the user that are available at the time. And if we do the get username API endpoint, this is like, suppose if someone wants to know who they have a shortcode, but they don't know what user this belongs to, they can use this index to look for the username. So for the shortcode, the user, we can use the get username endpoint with the shortcode as an input and obtain the username, and it's Madonna in this example. So let's look at the client-side JavaScript implementation, where the idea here is that there is going to be a client-side JavaScript library, which is named as UN extract for extracting the shortcode and the username pairs, and then post them to the add UN index. So what happens is, let's say a user is browsing Instagram post on Internet Archive. So when they are browsing Instagram post, it detects that it is it is an Instagram post, and extract the username and the short code of that from the URL, and then send that to our API. So the advantage here is that this will help us automatically collect username shortcode pairs as users are browsing content on the Internet Archive, and it will help us populate our index. So to demonstrate this, let's take a look at this particular shortcode username pair, which is instavideo_KAZ. So if this slide is just to verify that, so we have hosted 100 WARC response records for those top 20 most requested posts by using PyWayback. And we are just trying to show here at this stage, if we try to see that short code, who does this, the username for that short code, it says null. That means that this username is not available in our index. Now, this is the PyWayback search result page for that particular post, and you see there are 4 different captures. So let's say the user clicks on the memento from December 24th, and what would happen in the background is once this memento is replayed, our UN extract JavaScript will be initiated, and the username will be extracted and sent as a post request into our add_UN index. So this way that the username will be added to the index, and to confirm, if we now try to look at the username that belongs to this short code, you can see that it's instavideo_KAZ. So that's our very first method, and the preferred method of populating the index, I would say, because it would automatically do it as we go, and gradually our index will be populated over the years. Now, the second method is for by using different scraper scripts. The idea here is that, as you see here, the Instagram account, this is an Instagram account page, and this is a individual post. Both of them have this username included in the HTML. So what we are trying to do is grab the username from here, and to demonstrate this, we are using those 2,427 posts, which I explained from the IA Holdings dataset. So Instagram has imposed very strict rate limiting strategies. So we had to, it was challenging to overcome this, and to achieve this, we followed a distributed data collection method. So for these 2,427, we divided into different paths, 98 paths having 25 short codes each, and we made a call to that on the live web. So to Instagram.com, and downloaded the HTML for each of these posts. So from there, we were able to extract the username from the HTML for 1,594, which is 66% of the post. So what's left is 833 posts. They are not available on the live web. So we, as they are not available on the live web, we were not able to extract or download the HTML for those. Now, this is an example of a live web post pages HTML, and as you can see, the username is available at different places, which we can extract from, and what our scraper script looked into these different meta tags and try to extract the username one way or the other from different fields. So we use those 833 posts that are not available in the live web to demonstrate how we can extract the username from archived post pages. So we downloaded the CDX response for each post, saved in separate each post, and then save them in separate index separate files. So, for example, every short code will have a separate file with all the CDX response in there. And this came up to a total of 1.2 million URIMs in total for these 833 posts. So what we did is that we iterate through each post, try to look what mementos are there. So when we read the CDX, we got the memento date time and sorted it according to the memento date time, and started from the earliest memento and try to use our script to extract the username from the HTML of the archive page. So the choice to do this, like why we did it this way, to sort it on the order of memento date time and start from the earliest one, is that the recent mementos of Instagram are redirecting to the Instagram login page, which is a known problem to everyone. Now, to extract the short codes from the live account page, we used Katy Perry's account, and in 2020, as of September 24, she had 1,624 posts. And what we did is we used the Chrome developer tool, and we scrolled through her account page until the bottom, like where the very first post is, and captured the network traffic using the HTTP archive HAR format. So after download, after getting the HAR format, this is how it looks like. The short code for all the posts are available in the HAR file, and we were able to use the HARlyzer tool to obtain the relevant data field, which is useful for us to create the data set. So we were able to collect all the posts for all the short codes for her account at the time of the study. Now, in order to demonstrate how we can extract short codes from archived account pages, we use Blake Lively's Instagram account page. So there were 124 posts as of February 2023. And what we did is we collected mementos for the account page, and there were 3,854 URIMs. And this is how this is one example of a memento having different posts that belong to her account in the JSON format in the user object. So if you see, like, we have the short code available along with engagement, and then there are like 12 posts in one capture that we can extract. So we extracted those, and when we did unique on, because mementos, she doesn't post that often, and as you see, she only has 124 posts. So when we did a unique, we were able to find out that there were 87 unique short codes, and that's 70% of her posts retrieved using mementos. This is the last approach of extracting usernames and short code from WARC record. The idea here again is to get the username short code pairs so we can add it to the index. And so the WARC target URI has the URI-R, which also contains the short code. So we extracted the short code from here. And then the payload has the account username. For example, this postcode D belongs to the username user with the account username Kevin. So moving on to the exploratory evaluation, we looked into our IA logs sample, which is like we have from 2011 until 2021. This is like 1 day per every year, which is the first Thursday of February, an average day of the year. So number of requests, the table shows, like third column shows the number of requests, which are like row access logs available, logs available in each sample. And this column shows the number of requests, which are the number of requests for Instagram content. So as you can see, the number of requests for Instagram increases over the year, at least until 2020. But as a percentage, always like compared to the number of requests in total, it is less than 0.2% of the total. We also looked into the number of posts, like unique number of posts requested every year. And as you can see in the chart, so earlier we did not have any mementos and then posts, and then from 2013, we have a gradual increase of the number of posts requested every year, with a notable surge from 2020 to 2021, which is like almost twice from the previous year to now. And the table here shows like each year in our sample, the number of unique posts requested, and the third column is the posts that were already seen in the previous year. So to clarify or like to explain further, if we look at 2017, there are 725 unique posts requested, and out of that, only 7 posts were requested in any of the years before. So this shows that Web Archive users predominantly request for like new content every year. We have to acknowledge that this is just based on one day worth of data every year, but this reinforces our approach. For example, for using the client-side JavaScript, if the users are requesting new posts every time, it's the likelihood of our index getting populated is higher. Now, we also looked into the creation date of the post in the IA log sample, and we drew a multi-line ECDF for different years. So each of these lines represent a separate different year, and the x-axis is for how many months have passed, how many months have passed prior to the access log date. So like when it was accessed. Now as you can see here, these are from years 2013 to 2017. 50% of them have requested the posts that are within the 12 months. And similarly, for years from 2018 to 2021, like the recent years, the 50% of posts that were requested were actually created within the 24 months. So both of these charts, they show that most Web Archive users, they request for mementos of Instagram posts that are like created recently. So finally, I would like to discuss a quick overview of each of our approaches and their requirements in terms of these different criteria. For example, archive support and archive storage and archive computational power, which means like whether we need any, does the archive need to provide any functionalities or services for these implementations to work. And by external storage, we mean like, do we need or do we require any additional storage, not in the archive, any additional storage for the implementation to work, and the additional step for users, which means that does the user who is trying to use our approaches to find all the Instagram posts, do they have to do an extra step to get there? And finally, by Instagram, what's meant here is that whether there is any involvement of live web Instagram in terms of data or any interaction. So, for example, for the revisit records, we need the archives support to create these revisit records, not only to generate them for each of the Instagram posts. We need the archive to house them, as well as include them into the system. And if we look into all of these secondary index approaches, the external storage is necessary, because what we are proposing is to build an external index which can be stored somewhere else, not in the archive, which users can query first to get all the URIs and then query the archive. So similarly, that's why it's also going to create an additional step for the user. They can't just simply browse for Instagram posts and like it won't automatically work. They have to do that extra step. And if we look into the client side JavaScript, we need support from the archive to incorporate our JavaScript into their replay system, so that when the users browse internet, for example, internet archives, Instagram mementos, that would initiate our client-side JavaScript and send the username to the index. So it's going to require the computational power, as well as this method sends the collected data into the external storage. So we don't require these two. Now, for the live web live web posts and accounts, we definitely require to work around or like navigate through the obstacles that are posed by Instagram's strict rate limiting. And if we go into the archive, like post accounts, and actually even for WARCs, we do require computational power, in the sense that for archive posts and accounts, for us to collect the data, we will have to make excessive calls into the archive that may burden the archive, or for WARC records, we will require the archive to run our scraper script on their end on the WARC records to extract the usernames. So this brings to the future work and conclusion. Now, although we have provided an overview or like summary of the requirements and various approaches, but we have not quantified these each requirement, like how much of it is needed, like a precise amount. And also, we think it will be very valuable to evaluate the time required for constructing this index all the way. Like how much will it take to build an index of all the available archived Instagram posts in the Internet Archive? And we also think that the challenge here is that, as mentioned, like most mementos, although they are like listed in the time map or in the CDX, they do not have the content we are looking for. They are mostly, it can be redirections to the login page and other challenges. So we will have to overcome those to do such an evaluation. And we would also like to weigh the pros and cons. Like if we build this index, how scalable this is going to be. Like if we build it all the way, how scalable it's going to be also in terms of performance and security. So in conclusion, we discovered that there is a problem, or there's a challenge in performing account-based queries for archived Instagram posts. And the main cause of this is because of the URL structure of the Instagram post not having the username included. We propose two different solutions. One is by using WARC revisit records and by updating the WARC target URI to a URL which has the username included in it, and also a separate index which maps the username and shortcodes. We demonstrated these implementations by simple test archives and did a exploratory analysis. So we believe that our efforts will enable web archivists to make informed decisions. For example, in terms of like practicality and the requirement to use these methods, approaches on their end, and also in terms of users to allow finding these Instagram archive posts in the Internet Archive. So the code and the data is available in GitHub, and the link is here on the slide. And thank you all for listening to my presentation. I'm happy to take any questions.
All right, so the way we'll do this is we'll take questions from the general audience, and then we'll do questions from the committee, who are myself, Dr. Nelson, Dr. Forster. So general audience questions. Let me first ask for our attendees on Zoom. If you have any questions, you can either type them in the chat, I have that open, or you can just unmute and ask.
Hi, this is Sean Jones. I have a question. If you could go back to slide 77. Let's see here.
Is it this?
That's not okay. Yeah, I wrote down the wrong number. Sorry, but that's good enough. Yeah, but yeah, I guess it was 75. Okay, so I like your analysis of what's needed for each approach here. This is good. I was curious though, with the client side JavaScript, this is something that runs at the archive, right? Or basically is being run by the visitors page.
Yeah.
And where is it getting the information about the user again?
From the mementos itself, like during replay.
So it's actually in the header metadata for the metadata for the page. It's in the HTML.
It's in the HTML, yeah.
Okay. And with the scraper scripts, are you actually parsing the JSON that comes back from Instagram?
Yeah, it's the same location where the username is there. The only difference is that when we go to client-side JavaScript, it's looking at mementos, right? So Instagram UI has changed over the years. So we have made sure that we are looking at the right place based on the URIM date time, so that we are looking at the right place from the client-side JavaScript.
Interesting. Yeah, obviously, this is one of the challenges. The method's going to break as soon as Instagram changes their API.
Yes.
But that's just the nature of scraping. The other thing I was trying to figure out was, so what did you mean by archive computational power?
So it's basically just like whether there has to be any processing done at the end, I think. Maybe not worded properly.
No, that's cool. I just want to understand it. See, it's just in the case of the client-side JavaScript, they have to serve it, but the visitor is the one who has to play it back.
Yeah, so it's like they have to incorporate our JavaScript and like add it to the replay system, right? So, for example, in addition to Wombat.js, we are thinking, okay, they are already doing so much with that Wombat.js. So we think like there's an additional power they have to utilize for this JavaScript, also to like just initiate it, scrape the username, and then post it to our index. That's the idea.
Okay. Yeah, I think Ilya Kramer has had to do some similar things for Twitter, but this was a while ago. Okay, I don't have any more questions at the moment. Thank you.
Thank you.
I think you mentioned you already have different scraping scripts
Yes.
based on time.
Yeah, I think I have it here.
You might want to repeat that for him.
Yeah, so as you can see here, we were like trying to grab the memento date from the URIMs. This is all trial and error method. So up to our understanding as of right now, this is how the date range occurs, and between the memento time of, for example, from 2012 January to 2014 January, this is where the username is like where we are grabbing the username from at this stage. So similarly for these different ranges. So we don't have after 2020 because we didn't look into that since most of the Instagram posts are redirecting to the login page.
Okay, this brought up another thing. Now, could someone use this technique to determine, at least using web archives, how often they change their backend API?
I think that's a good way of doing that, like by utilizing web archives to find out how often a web page changes the user interface.
It would be cool because it would be neat if you could actually tie it to real world events, and then you could figure out, perhaps this influenced that behavior. Okay, yes. I'll give some other people some chances to talk. We can talk later.
Okay, that's a nice idea.
All right, so anybody else on Zoom, just let me know if you have a question and I'll recognize you. But now anybody in the audience would like to ask a question?
So slide 45.
Oh.
I think it's 75.
I think 75?
Yeah.
Okay.
I really like this table. So
thank you.
You have the Instagram field.
Yeah.
Where it tells whether you need you said it needs workaround in Instagram's date limiting.
Mm-hmm.
So what are the workarounds that you use? Okay.
So main thing is we tried all different ways of trying to get from collect data from Instagram. I think I have a summary slide maybe. Yeah. So some of the challenges actually. So one is that we tried doing the usual techniques that people do to get out of the rate limiting, like try to be careful in a request to make sure that they don't detect us. So one is the addition of sleep times, and we tried rotating the usage, and we tried different free proxy services. We even tried the Tor browser, which has different layers through the command line, and try to add it. But somehow Instagram has that's why I mentioned that it has a very strict way of detecting. So somehow we got blocked in each time. So what we did was, if you remember, like I asked all of the members in our groups help, we created different small like subsets of short codes and distributed among our group and asked them to run it. So mostly like it will run us scrape a scrape and get blocked. And then we slowly collected the data, like we waited the penalty time and then tried attempting again. So it was a very slow data collection process. And one other interesting thing we found out was one of our colleagues, Leslie, she found out that we could use the mobile data. So as you know, when we disconnect and reconnect, some service providers provide new IP every time. So if you try to do your data collection, disconnect and reconnect, it somehow didn't detect. So by using mobile hotspot on our script, she was able to do like 10 or so like paths, which helped a lot. So at this moment, I would like to acknowledge the help from everyone in in our data collection process. I hope that answered your question.
David?
Yeah.
So the scripts, the scripts are just run manually, right? Like you run the script and then it goes in to Instagram and gets
Yeah.
saved and stuff.
Yeah.
I was thinking, have you thought about maybe like a Chrome extension or something that just kind of sits there so it doesn't go out and do stuff, it just kind of like the user would log in and just do their normal Instagram, specifically for the live web part where you're trying to get the usernames with the IDs and things. The user can just like log on Instagram and just be using Instagram normally, and then the extension can maybe just be kind of watching the page as they're going or whatever they're doing, and match the usernames to the IDs as they go, and then maybe submit it as they go or have a buffer and then submit like chunks of it and stuff, so it's not kind of
That's a great idea. We haven't thought about it, but now I think like the challenge, or we did not do any logged in methods of data collection in our study. So we realized that the logged out version had more metadata. So that's why we didn't go there, but that's a really great idea. We didn't think of it actually.
But if you're logged out, it would still throttle you.
Yeah,
So
even if we are logged out.
I don't think you can get there.
Well, if you're logged in and you just have the extension kind of watching the web page,
The
and it's not
metadata that you need is as an end response. It actually sends different HTML depending on if you're logged in or not.
it won't give you like the post ID as your like
But
when
it
you
won't give you the user information that you need to extract from the Open Graph JSON. When you're
But if
logged in, you actually get a stripped down version of the HTML without the structured metadata. That's only present if you're logged out.
But you really just need to look for the username and then the post ID, right? Is what you're trying to match. So if you have the URL, if you're scrolling down and Instagram gives the user as they're scrolling down, here's like 7 posts as they're scrolling down, they click on one to go get the details for that post. Would the ID be in the URL for that post? Like you have the grid of
Short code will be in the URL. Yeah.
So like if they're on a user's page, the username is even if it's not in the URL, it's somewhere on the page, basically, like in their next to their profile picture and stuff. And then the URL, the ID for the post would be like in the URLs for like on the image grid that you would click on one of the images to expand it. So
I think that would work, but basically because like we were trying to create our data set, so since the logged out version had more metadata, we preferred that one. But I think what you are suggesting would work, because even in the logged in one, you do have the username, which is like a basic thing for the account. Yeah.
So now that you talk about the data set, I'm wondering like how do you store the data and the technologies behind that? Like how you would basically get after scraping the data.
Or like the index, you mean?
Yeah, like how did you store them?
Yeah, the index is like at this stage we have a SQLite 3 database. That's where the scraped username shortcode pairs are created, and then we have a Flask API providing access to our SQLite database. I know it's like, since this is the prototype, so we think like in the future, if we are taking this to the production level, we can use, we can port our code to a much more reliable, like a larger database like Postgres or Postgres SQL or Oracle, I think. But at this stage, it's on SQLite 3.
Other questions from the audience?
I was keeping for the end. A lot of questions and comments. Yeah.
From
Thank you
the
so much.
archivist.
Yeah.
Yes.
If you could convince someone from the Internet Archive
Did I?
how beneficial it will be for the Internet Archive, we might be able to run a process that goes through all the access logs one day at a time and build it somewhere like as a batch process in the background, right? Convince me how useful it is.
I thought I did. Okay. Okay.
Sure. So anyway, so that aside, I think either I missed or you failed to report when you. I know you did not look at the log data on the consecutive days, but even in a single day, if you think of it as a chunk of half an hour or an hour or something like that, going from one band to the other, how many of those URLs were accessed again and again? In any situation like this, I would hope something like 80-20 rule be applied there, right? So when you are building such data sets, what happens is over the time as you collect more and more, your gain is not as much as you put your effort in, right? So at some point you'll have to kind of stop, right? So even if you look at a single day worth of data set and you see, oh, this account kind of had millions of recurrence of the same request or something. So you're not learning a lot, right? So over the time, how would your learning growth happen? Like, I mean, I think it would be a heaps lockup or something like that you might look at.
Yeah, we haven't done that. We just did the initial analysis with the number of requests, but it's a great idea. Like I think how we did for the paper with access logs for like who is accessing the web archive use analysis. So I think similar to that, if we did by different chunks, like you are saying, and look into it. I'm thinking in my head. So we don't have different post requests. If you see, like it was everything was within 2000 or like less. So I'm not sure how like on that particular data set, how we will be able to, like on the chunks, there will be a lot of gaps, I guess, but it's definitely a thing to look into.
So, I mean, I think a motivation behind that question was basically, if we somehow know the learning rate, then if we are processing, say, all the logs, access logs, we can skip, right? So process one day and then skip 2 or 3 days and then process the next one, hoping that when we do this way, most of the important accounts will be encountered without processing the whole thing, right?
That's true.
But probably what keeps it from being Heaps law is we are learning new shortcodes or creating new shortcodes at a much faster rate than we create new terms in human speech, right? We do make new terms, but at a much slower rate.
So that was another question I had. The shortcodes, one account has multiple shortcodes, right?
Yeah.
And the shortcode doesn't belong to post, it belongs to
It belongs to the
account.
post. Shortcode is for the post.
Oh, it's for the post. Okay.
That's why it looks like.
Yeah, it's like the ID and
ID
Twitter,
of the Twitter.
but
Yeah,
there's no
got it.
account information.
Yeah. That would be too much. Otherwise, I was thinking like a database, like something like DBpedia or some of the kind of open data sets like that would be helpful, where we can put all this information and people can query like, hey, Katy Perry, give me all the shortcodes of her Insta account or something like that, right?
One thing that we do have, so there's a large Instagram population, but even the most popular accounts have a small number of posts,
right,
as opposed to tweets, which are text and easy to generate. In Instagram, you create a small number of like really perfect pictures and upload those. So she has hundreds of posts, or I mean, not 13,000 posts like you would on a Twitter account.
On your slides, that session ID thing was covering, so I did not know the slide number.
Oh,
but
okay.
in one of your API responses, you were showing null.
Yeah.
Go to that post. That page, please. I have some concerns there.
Yeah.
I'm reconsidering your report evaluation.
Yeah.
I've already put a comment on the slide.
I think the 200 response you made.
Yeah. There it is.
Right,
It's a soft 404.
Yeah. There's soft 404, I'm not expecting that.
Yeah.
And the other problem is, even if you're reporting that, the null is not a string, it's a special keyword. You don't have reports around it. Otherwise, it will be an ID with
username.
Okay. I thought about it. Okay.
Yeah. I'm not too clear about your exploitation of revisit record and using that as a tool to kind of store it. Maybe I can discuss that.
Okay.
Later. I don't want to take over that.
Yeah.
So how many you get to the stories apart from the posts? Like, were you able to like get any archive stories?
We haven't looked into. One thing is, I think it will be,
Wait, can I ask it? So are stories videos or are they just
It can
not
be.
an Instagram?
Videos and pictures or text and everything.
Yeah.
So is it temporary?
yeah,
They-
24-hour thing.
Dr. Nelson mentioned that they many, even though they are famous, they just have less number of posts. But celebrities, they keep on posting stories like every day. So that's a lot.
Yeah,
That's why I was just curious whether you have you looked into that.
we haven't looked into,
Don't they
but
have a
yeah.
separate prefix instead of /p?
I don't know.
Use it on mobile.
I don't
Yeah,
know.
that's the
Yeah,
thing.
I
But
used
I
to
have
know
seen
it.
the real.
And that's why nobles. URLs underneath.
I have seen the real URL, which is similar to the post. So Instagram.com/real and ID. So this is like another user case where these approaches can be used.
I bet it has a different prefix. I mean, but it's probably the same problem.
Yeah.
So your API has something called get shortcode or get username. Revisit RESTful URIs versus RPC.
Okay.
Right, other questions from the audience?
Great work indeed.
Thank you.
My question builds on Sue's question, if we're going to go. to
Yeah.
next.
Come
So can you go to
time.
slide 83, please, your final slide? So on this, my question was going to be, suppose that we could make a recommendation to someone at the Internet Archive. And they said, we're going to run the service somehow. Of your two solutions, which one would you recommend? You explore two, that's great, that's what we do, right? But pretend we had a commitment. Like Sue talked to Mark, Mark said, absolutely, we need to do this, do whatever it takes. What's your recommendation to Sue?
Then it would be the revisit record, forgetting about all the requirements. It will be the revisit record because that will be the most user-friendly, as well as we just have to do a small change and everything would work automatically with the things that are like with the existing technology. So I think that would be my first choice. But if not, like the second choice will be to give our script and run it on all the WAP files that's there to like build our index. So it won't burden them. It will be like a request to, can you run this and provide us? So Internet Archive has compared to the other archives, I would say like if we run it there, it's likely that we will get most out of it and we can add it to our index.
So now I understand your revisit record.
Okay.
I'm not very comfortable with going through revisit records. It's kind of an
Different analogy.
yeah. This is basically the very different purpose. Revisit records have very different purpose. It's a unique visit that was or observation of a resource that was done by the crawler. But we found, and that generally happens after the content was downloaded and metadata was matched, especially that content digest was matched. At that time, it says, we don't have to keep this payload here. We can throw it away and we'll find it out where it is. So that is the essence of revisit record.
Yeah.
Some archives do it per URI. So a revisit record will be bound to the same URI. And if that is the way this will not
Yeah.
work, I think you are especially trying to tie in two different URIs for the same thing, right? Though revisit records, by definition, they are not necessarily preventing people to do deduplication across URIs. I think in some recent crops, we were mentioning those things.
We had a hint and we tried and it worked. So,
logically speaking, a more sane approach would be to use a resource record. The problem is we do not ingest resource records into our index.
okay.
If we were to fake it, I think a synthetic 301 or 302 type response record would perhaps be more suitable in this case. Could be a response record or a resource record with basically redirection there. Revisit basically creates a very new entity with whatever date time. So yeah.
We understand the revisit record is for like partial or full duplications, like to avoid those. We can create like much smaller. It's smaller in size. I think that's the whole point.
Revisit record only deduplicates the payload, not headers. It is a new observation that we're talking about. So we were thinking about and we did not implement it, but we were kind of considering that this redirection technique. So one of our partners are from a CC. Whatever people archive there, we get a copy of that basically, and they use us as a kind of application. Now they use these short names basically, or IDs in their URLs, not the traditional URL syntax that people have, right? Where the original URL is part. They support that, but generally they advertise the short one. Now we have a copy of say therma.cc/abcd-1234, right? How would we know which URL it belongs to, right, on our end? The information is available, obviously, at the time they provide metadata where we can look into it and all. But if tomorrow that service goes away, PermaCC goes away, and if someone has PermaCC URLs on in the papers or whatnot, and they come to Internet Archive, we will not find that copy because we don't have the mapping available, like that short code belongs to which URL. So what we were thinking is like we can create a redirect record where the source URL will be PermaCC/whatever is their code, and that will redirect to the memento that we have that was kind of ingested from their thing. We have not implemented, but we're considering this. So
that will be an approach for this as well then.
Somewhere in the work record, is there a place where you could stuff to say this is a fake 301?
Oh yeah, of course. Yeah. Okay. If we do that, we'll have enough metadata to say that, and we'll perhaps,
because that would be a nice approach, right?
Oh yeah. In fact, even what I was thinking, and I'm still kind of looking up in my head, like basically the response, payload response of these redirect responses are generally not seen by people when you are browsing from browsers. But if someone is doing like a more kind of an interactive client, at the payload time, we can provide more information in there and say it out loud and provide some specific headers to be very specific about it. Like, hey, this is not a real. So I mean,
not a real HTTP.
The idea was to leverage the infrastructure we have for playback rather than inventing a new index somewhere where someone has to go look back up. Like, I mean, we can talk about all sorts of other things like these URL shorteners and all that stuff. Why build another service for that when we can somehow put it into our own access?
Yeah, we did not try to like quantify, but I think some of Haley Bragg's work relates to some of that, like talking more about these archive redirections, but Instagram redirections to the account page. But I have seen a lot of them. That's why some of these decisions I made in looking into the mementos were based on that, trying to like document them. Maybe a blog post about this redirecting to the Instagram login page.
Right. Yeah. So yeah, and another thing is that so in this two approaches that you mentioned, so does the both of them work for all of the Instagram accounts? Is there any limitation, any changes, or all of them can be, all of the Instagram accounts can be kind of like that with these two methods that you mentioned?
You mean like the public accounts and
Yeah,
private?
I mean that, is there any kind of restrictions in the Instagram accounts that you want to kind of retrieve them, look at the archive?
Yeah, so for using the live web method, like for example, Katy Perry's account we use, it's a public account, so we were able to, like without login, scroll through her account and capture. But and in general, like there's no restriction if we are looking to archive, and if there's an archive copy, that if they were able to capture it, all of those approaches where we are looking into the archive web, there's no restriction at all. So I think that's it.
And then, yeah, that was one of another things
Okay.
to just kind of add to Michael's and Suat's thing to just considering as a feature to be added to the Internet Archive Wayback Machine. That could be really kind of useful thing for other.
Yeah, so you mentioned like you were scrolling, I think, at a very page and keep going until the end of the first post or something like that.
Mm-hmm.
Did you consider something like some of these interactive archiving systems like
Conifer.
Recorder or something like a Conifer, right?
Yeah.
Where you can actually program a little behavior. That's what he calls it.
Yeah, we tried that, and it the session was crashing, I think, towards the end. But so although it's only 2,000, I think she had like 1,600 posts, but it would like it took so much of my browser. It's trying to do I tried using the automatic scroll. They have like different behaviors, like you mentioned, and it did not work. So, but we tried this method of capturing network traffic. So I think the idea is same what he's doing by recording the browser sessions with the Conifer, which should ideally work.
Well, I mean, the data you'll get will not be hard file, but
No,
a WARC file,
WARC file.
which is more familiar to archivists.
Yeah.
But
Now,
I
in
did
fairness,
smaller
you
sessions.
tried this was a year or so ago.
Yeah, a long time
That's-
back.
Things may have changed.
Yeah, that's true. At the beginning, this was in 2020, not even a year.
All right, so let's see, I have a couple questions. So the account page has additional shortcodes as we were talking about. You can discover additional things there. You could get the 12
Yeah.
that are in the image. So do post pages have any additional information, like other shortcodes that could be mined? Like you can kind of walk through, once I go to the account page, I can get these 12 post pages, and then maybe each of those 12 post pages has
So
like a next post or
in the
something.
post page, in the data, like in the JSON data, what I mainly saw was you have the post information, but if someone is commenting, their user account details are there. So like someone else's, like whoever is engaging, likes, comments, those user account information is available with like timestamps of that comments and like,
Right, but no other like
no
short
other,
code information.
short code information, unfortunately.
So, and then, kind of based on, I know you haven't done the, analysis for, what type of storage might be needed to support, this at the internet, whether you did revisit records or whatever approach. But assuming there are like, 1 million archived Instagram posts and, most of them aren't going to be accessed very often. What would be your recommendation in terms of how to prioritize Internet Archive's resources? So if you had a fixed set of storage that they could allocate to this, what would you put in that storage?
I think I'm not very clear with the question.
So say there's, 1 million archived Instagram posts,
Okay.
right? And so to do this mapping.
In the archive
need-
or?
In the archive.
Okay.
So to do this mapping, right, you need some record for every single post,
Mhm.
right? Because you have to have post and username. But what if that Internet Archive wasn't going to give you the resources to do that for all 1 million posts?
Mhm.
How would you recommend that the storage be prioritized? In terms
Okay.
of what posts would you prioritize?
Maybe the posts that are likely to be like requested more, like, so we saw different user cases. For example, some accounts, like what accounts are interested by the maybe general public or researchers. In terms of that, maybe like, for example, okay, we know this, there are the disinformation spreading accounts, and then there can be like accounts, maybe like government officials, or like we can look into those and try to prioritize them rather than like my account page or yours, I think.
Oh,
Like,
I did say I don't
Yeah.
use Instagram, so that's probably a good choice.
Okay.
What about slide 74 with the information that you discovered from slide 74? Would that help?
Yeah, the recent post. Yeah, like, because we know that people are requesting the recent post, like recent post, it means like these are the date of the creation of that post. In one of the other studies, like using that, like using the short code similar to what we do with Twitter Snowflake ID. Using the short code, we estimated the creation date of these Instagram posts, and based on that, we created this chart. So as we can see, like this is from 2013 till 2021, like at least they are requesting the most recent posts. So like you said, we can prioritize the posts that are recent, but I'm thinking how we can identify and like make a recommendation based on that.
I think post was recent at some point when you are talking in terms of archival analysis, right?
Yeah, so it should be like relative to now, recent relative to now, and like keep prioritizing them also, like switching or moving it to somewhere. I don't know how the like architecture is there, but yeah, if it's limited.
So to build on Yasmin's result from like 10 years ago or whatever it is now, we know you can check the referrer log to see if links are coming from Wikipedia.
Mhm.
We know those will be high traffic,
Mhm.
right? So even if it's an old post, if
Yeah.
it's getting traffic from a high traffic site, you might juice the
Yeah.
priority like that.
Yeah, that's what I was like. That's my first thought. Like, what do people request? If we try to quantify or like try to find some rows. Okay, these are the things that people are looking for. Maybe prioritize that, but and also the recent post. It can be a whole other study, I think.
And there is also common sources of these things could be like Internet Archive has a browser extension.
Mm.
And as you browse the web, depending on your extension settings, it might query our services to see how many copies are there, and do we need to archive it and stuff like that. So the problem I think in browser extensions is you can't really override user agents in some of these things. But I think they do allow adding more to user agent, I guess, rather than completely replacing it or adding other.
But there are extensions that allow you to change your user agent, right? Yeah. So you might, I don't know what the rules are based on browsers, but some browsers have it built in, and some you have to get an extension to change your user agents.
From developer tools, you can do that when you have a the tools access.
Yeah, there are extensions where you can add complete new headers if you want and replace the ones that you would normally send.
Right.
So
Yeah, that is something that we do, but the problem is now you'll have to surface that header in your logs. So you'll have to configure your access log so that it logs those additional headers, right?
Going back to Dr. Wiley's question of priority, does Instagram have verified users?
Yes.
They do, right?
Yeah.
Did you look at that at all in your study, like where the top 20 that you found, that then you got the thousands, were those mainly verified users?
No, we haven't looked at that, but I remember initially, like, if it is verified, in the metadata, we can look like it says verified true, or like we can collect and definitely look into that.
Because they have the old Twitter style of verified where you have to be given and nominated for it.
Not
So
favorite.
that might be like some kind of super user.
Yeah, that's true.
Right, and probably unlike Twitter, there are no journalists, well, not using it for journalism. So you probably verified or strongly correlates with popular. And but I think most of those top 20 probably were there because I recognize most of them. And I'm sure Madonna and everybody is verified.
I think it correlates to number of followers that you have, the verified thing.
That can get a bit in our bias.
Right, any more questions, committee questions? All right, thanks again.
Okay, thank you.
Okay, so we're gonna excuse everybody, the committee will confer, but Whistle folks, go downstairs, hang out a few minutes. We're gonna get a group picture of the folks that we have, and we'll be down in a couple minutes.